Okay, so let's talk a little bit about where we are in terms of Java in 2021, because there have been a lot of things that have changed in Java over the last few years, not just from a technical perspective, but also from the way that Java is, well, delivered and also developed. And so Java is now 26 years old, which I find quite kind of scary because I joined Sun back in 1996, which was about the same time that JDK 1.0 came out. Java had been around for a little bit before that. But I kind of followed Java all the way through the Sun years and then Oracle and then Azure now. And I was just talking earlier on and doing a bit of an interview. And one of the things about Java, the way that it's maintained its popularity is not because of the language itself. Although the language is great and very popular, the real power is the JVM, the managed runtime environment. The fact that you've got this thing that you can run applications on. And it's not just obviously Java that you can compile into bytecodes. You can use Kotlin, you can use Scala, you can use Clojure, many different languages. And that's the real power because of its scalability, its ability to deliver on those kind of workloads. What we've seen in the last 4 years since JDK 9 is a change to the way that Java is developed. Now we have a new release of Java every 6 months rather than before where it was every 2 years, maybe every 3 years. In extreme cases where between JDK 6 and JDK 7 it was over 4 years between releases. Now this is great because it means that we're able to deliver small changes much more quickly than we have in the past. And I think as we go through certainly the technical part of this presentation, we'll see how many things have been added to the language over the last 3 years and how that makes the programming in Java a lot easier. They're taking some of those kind of rough edges off. And one of the other things about changing to that 6-month release cadence is it means that we can then also use this idea of incubator modules and preview features. And that's really good because it means when we add something to the Java platform, in the past, it gets added and that's it. It's fixed. So if you don't like it, you can kind of try and get it changed, but it's very difficult because it's baked into the standard. With the 6-month release, what we can do is we can say, right, let's have preview features, incubator modules. We'll add the features to the language, but we won't make them fixed straight away. Let's let people try it out, give some feedback, and if they think things should be changed, we've still got a chance to do that, which is really good because it means that the programming language then fits more with what people really want rather than what the developers think people really want. And we'll see some examples of that as we go through how that's worked really well. Now, the other thing about doing that is that it does pose a challenge for people who are using Java for enterprise applications. Most enterprises don't want to change their Java version every 6 months because that means doing an awful lot of testing and an awful lot of proving and all sorts of paperwork that needs to be dealt with. So we have a solution to that, and the solution is long-term support releases. Now, Oracle came up with this idea when they released JDK 9 and they said, let's switch to one every 6 months. And they said, right, certain releases we will provide extended updates to, we'll have support for those, people can use them in production, they can deploy them, and that's all good. The in-between ones, you can still use them in production, but if you want to continue getting the support and the security fixes, you've got to change every 6 months. So you've got a choice. And that's worked really well. So we had JDK 8 as a long-term support release, then JDK 11 became the next one, and just recently, in September, we had JDK 17. So every 3 years was the idea of LTS releases. One of the things Oracle announced at the same time as JDK 17 was that they wanted to shift to a 2-year cadence between long-term support releases. And I think it'll be interesting to see how that works out as to whether people think that's a good idea or a bad idea. So let's have a quick show of hands. So who thinks 3 years is good for LTS releases, between LTS releases? Nobody. Okay, 2 years between. Okay, a couple of people. Less than 2 years? Oh, okay. More than 3 years. Oh, okay, so quite a broad spectrum of views on that. That's quite interesting because I thought most people liked 3 years, but apparently that's not the case here. So essentially, what we're going to see is the next long-term support release will be JDK 21. Now, the other thing is that because of some of the changes that Oracle made in terms of the licensing of the Oracle JDK, what we've seen is a proliferation of builds and distributions of OpenJDK. So let's talk a little bit more about that. So OpenJDK is open source Java. Sun released the code for Java back in 2000, well, started in 2006, 2007. And that has been the way that the Java platform has been developed in the open. It's the reference implementation for the Java SE standard, and that all works very well. And what we've seen is this has been very successful as an open source project. We've had clearly Oracle as the owners of the Java trademark. They own the OpenJDK trademark. They contribute the bulk of the code that goes into new features. But lots of other people do as well. And it's individuals, it's also companies that are very heavily invested in this. Amazon invest in this. Red Hat have a big consideration. And Azure, who I work for, obviously we contribute a lot as well. So that all feeds into the open source project, and then it makes it available for people who want to build a distribution. It's very much like Linux. You know, you've got Linux, the open source project, as the kernel, you've got the libraries, and then people come along and they say, right, I'm going to create a distribution, whether it's Ubuntu, Red Hat, Debian, or whoever. So now we've got a choice in terms of Java. If you want to run your Java applications in the past, you'd always use the Sun JDK, you'd always use the Oracle JDK. Now you can use the Oracle JDK if you want to pay a license fee, or you can use Azure if you want to use it for free or pay a license fee, or you can use Temarin for Adoptium, that's a free one. Amazon have Corretto that runs on AWS, you can also use that for free. Even, and I find this quite surprising to say this, Microsoft have a distribution of OpenJDK. It's not J++, it's not J#, it is actually a build of OpenJDK, which they haven't modified to break the standard. And so they are back into the sort of field of Java again. So this is what we're seeing now, is this kind of proliferation and choice for you as developers. Okay, let's talk technical then. So JDK 12, what I'm going to do is I'm going to go through all the language changes that happened between JDK 11, the last long-term support release, and JDK 17, the current long-term support release. So very logically, I will start with JDK 12. What we got in JDK 12, and all of these language features are delivered as previews, meaning they're not part of the standard straight away, and we've still got the opportunity to make changes if we want to. Switch expressions. Now, if we think about Java, the programming language, from the very beginning, we've had switch statements. That came from the C programming syntax, and it was brought into Java because that was familiar for a lot of developers. But switch statements are a little bit sort of error prone. If you think about it, when you've got a set of case statements, you do something in your case statements, and then you've got to remember to put a break statement in. Otherwise, you fall through into the next set of case statements. Has anybody here, like me, ever forgotten to put a break statement in a case block? Yes. Pretty much everybody has. Oh, there we go, the yes today. See, because even when the IDE is very good for you, and it helps you, you can still make that mistake and forget to do it, and then the way it's designed to work is to drop through into the next one. And that can lead to behavior that's very difficult to figure out and solve the problem. So you get things like that. There's also issues around things like the scoping of local variables if you use those in case blocks and things like that. So the switch statement has been a little bit error prone. If we look at a very simple example of how we would use a switch statement in Java before JDK 12, this is a simple example. What I'm doing is I'm switching on one value, the day of the week, and I want to assign a value to another variable, the number of letters. Very common pattern for using switch. So here, what I'm doing is I've got lots of lines of code. So I've got my switch on day, I've got case Monday, case Friday, case Sunday, set the number of letters to be 6, and then remember to break. And then obviously all the other cases as well. As I said, one source of error is forgetting to put a break in there. Another source of error would be to forget to set something for the number of letters in a particular set of case statements. Now, the compiler will catch that if I'm using a local variable, but if I'm using an instance variable that is pre-allocated, then I might miss that. So there's things like that that make this difficult. So in JDK 12, we get switch expressions. Immediately, if you look at this code, you can see it's a lot shorter than the code we had before. How this works is we move away from simply using a statement, which is where we execute some code, but we don't generate a result, to an expression which delivers a result that we can assign. Great, because immediately we solve one of our problems. We make one assignment. We set the number of letters to be the result of the switch expression. Assign it once, we don't have to remember it for every case block that we've got. Then we can see we've obviously got our switch on day, and the bit that really just like blows my mind here is it's taken 25 years to figure out that there is this thing called a comma separated list. So rather than having case Monday, separate line, case Friday, separate line, case Sunday, we do case Monday, comma Friday, comma Sunday. Put it all on one line. Who would have thought? Anyway, then we have the arrow operator that we borrowed from the lambda expression, and the right-hand side of the operator is the value that will be returned from the expression. We assign that, great. And the great thing is that the compiler can obviously check to make sure that we've got all the things that we need there, and a value is returned from each set of cases, and that's all good. And if we need to, we can throw an illegal exception. We can combine the old style syntax with the new style switch expression, but that makes things a little bit more complicated. So now we're doing the same thing. So we've still got our case Monday, case Friday, case Sunday, separate lines. And in this case, we're not using the arrow operator. The designers decided to overload break with a value. Okay. Well, you can use break from a switch statement. That's fine. But you can also use break in a loop, and you can break to a label. Okay. Quick show of hands. Who here has ever used break with a label? Good, nobody, because it's kind of like a go-to. So it's not really nice. But anyway, so the point is that because a label can't start with a number and it cannot be a number, the compiler can differentiate between where you're breaking with a value that's returned from the switch expression versus breaking out of a loop that your switch expression might be in to a label. So that will all work. But it's not really that nice. So we'll come back to that. JDK 13. Another 6 months development, and what did we get? Well, now we have text blocks. This is great because, again, Java as a programming language always had the ability to create strings, and we can have string literals defined by double quotes. The problem has been how to create multi-line strings, how to include special characters, things like that. There are ways of doing it, but it's, again, more complicated than it really needs to be. In JDK 13, we now have the ability to create a text block by using 3 double quotes to indicate the start and the end of the text. So we borrowed some syntax here from Python, because Python does it the same way. Great, so people are familiar with that. What we see is that we've got some HTML tags, and we can put those on multiple lines. And as I say, everything that goes up to the next 3 double quotes will be part of our text block, part of a string. Obviously, we might have a situation where we want to have 3 double quotes inside the text block. That's fine. All we need to do is put a backslash in front of at least the first of the 3 double quotes, and then we can escape it. Now, if we print out what that code will actually generate, it might not be quite what you expect, because what we're seeing is we've got our HTML tags neatly indented in the way that we want them to, but they're left justified. And if we look at the tags there, they're actually pushed over to the right. So why are we eliminating the space between them? How do we know to eliminate some space but not all space? And this was the idea that they had in terms of designing this feature, which was to allow incidental white space. The reason for that is because if we had to push our tags over to the left-hand side, it doesn't really help the layout of our code, and it doesn't make the code really that readable. So we might want to put them over on the right-hand side so it kind of helps the layout of the code. Everything up to the first character is considered incidental white space. So that will be stripped out. And then it means we're not just stripping out all white space before any characters on a line. We still get the indentation that we expect for the tags, but we don't get the white space that's part of the layout of the code. The other thing to note here, question?
Would it make a difference if you put the first element directly after the three quotes or not?
Do you know, it's almost like you psychically thought the question that I'm about to answer, which is you must follow the first three double quotes with a new line. So no, you have to put the first text on the next line, and essentially that gives you the idea of how much incidental white space you have. The other thing that they did was that if you include some white space here after a tag, they strip that out. Now, I don't know why they did that. I still don't quite understand the rationale behind that, but they decided to do that. So what we can do is we can also decide that we do want to move our tags over by a certain amount and include some sort of padding on the left-hand side. And we can do that by moving the three closing double quotes onto the next line and then pulling them over to the left-hand side of it. What we then end up with is some intentional indentation, so the 4 spaces that we want to have padding our tags, and still some incidental white space that we want to eliminate. Again, if we print out what the results of that give us, then we see now we've got our tags shifted over by the 4 spaces that we want for our intentional indentation. However, there is one just tiny drawback here, which is that we get an extra blank line because we've had to move the 3 double quotes onto the next line, and so we get a new line. Okay, I'll come back to that in a moment. Switch expressions. Hang on, I've already talked about switch expressions, so why am I talking about them again? Well, I said that they wanted to overload break with the number that was going to be returned from the switch expression. And people looked at that and they said, yeah, we don't really like that. It's possible for the compiler to determine what's going on, but it doesn't really make everything as readable as we want. So the designers said, you know what, you're right. So we'll change that, and rather than using break, we'll use yield. So now we use yield as the word, and so there's no ambiguity between are we breaking to a label or are we breaking returning a value from the switch expression. So this is a good example of how the preview features work because it still allows time for these changes to be made. JDK 14. What did we get there? Well, JDK 14 was, for me, was one of the better releases because it had quite a few really powerful things in. First of those relate to data classes. So I had a little bit of my thunder stolen, but that's fine because there's still plenty to talk about. In Java, we often do things like this, where we create a simple data class. And in this example, I've created a point which has 2 values, x and y, both of which are doubles. Okay, well that's fine, that's just standard Java code. But the problem is I have to create a class called point, then I have to have 2 instance fields, x and y, final doubles, then I need a constructor with parameters. I need to say explicitly that I want to assign the value of x to the instance field of x, y to the instance field of y, and I need accessor methods to get the value of x and y from there. 14 lines of code to basically do a tuple. I've always thought it would have been really good if we had tuple as one of the standard Java class libraries. And I did talk to Brian Gertz about this, and he said, well, that's great. Yeah, we could put a tuple in, but then you'll want a triple, and then you'll want a quadruple, and then you'll want a 5, and where do you stop? And that's fair comment, although, you know, I would have liked a tuple. So now we have records. And as Iva said, what we do here is we simply say, create a record called point, which takes 2 values, double x and double y. That's 1 line of code versus 14. The compiler is effectively doing all of the rest of it for us. So it's syntactic sugar for a data class. There is a little bit more to it than that, though. So records are really a special form of class in the same way that enumeration is a special form of class. You've got the braces, which means there's a body to it. You can add extra functionality if you want. Now, because a record is just a special form of class, you can make it generic. So if you want to, you can add a type parameter, you could have record anything of type T, and then you can store anything in it that you want of type T, and that will work. You can also add more logic to the record if you want to. Now, you can add static fields to a record, but you can't add any instance fields that are not defined as the record definition. So in this case, I've got the radius of my circle. I can't then create any other instance fields that are not specified in that circle definition. Static ones are fine. And then I can add extra methods if I want to. So one that determines the area of the circle with pi r squared. That will work quite happily. Question?
Can they implement interfaces as well?
Absolutely you can. And in fact, my next, see, this is great. This is, you're ahead of me here. So the thing is, the base class of all records is java.lang.record. Now what that means is you can't extend another class as a record. But because we can implement interfaces, we can do as many interfaces as you want, and you can provide the implementation of the methods in the record. So that's fine. You can do interfaces. You just can't extend another class as from a record because it's single inheritance in Java. Because it's a special form of class, you can override the equals, the hash code, or the toString methods. Versions are provided for you as part of the base, but if you want to, you can provide your own implementations of those as well. Records are also implicitly final, meaning you can't then extend it further. So you can't inherit from a class, you can't extend it. It's really records are records. That's all they're supposed to be, is data types. You can add the modifier, make it final if you really want to, but it's irrelevant because it is implicitly final. Records do not follow the Java Bean pattern. So we've already seen this in the example that Iva talked about. So you use the X method to get the value of X rather than get X. And as was rightly pointed out, if you really want to, you just make get X and get Y, and that gives you the get X and the get Y accessor methods, and that will solve the problem of your JSON. No, it was JAX-B, wasn't it? That was the issue. Record constructors. Now, often what you might want to do is to include additional logic in your constructor. So it's not just assigning the values, you want some additional logic there as well. And you could do that in a couple of different ways. First of which is you can use the canonical constructor. This is really just the same constructor you would have in a normal class, and you say, I've got my record called T-Rex, takes two values, X and Y, and I can then provide a constructor which is the full definition of that. So it's public T-Rex, takes int X, int Y. I need to test to see if X is less than Y and do something, but I have to remember to explicitly put in the assignments to make sure that the instance fields are set. That's obviously losing some of the usefulness of eliminating all the boilerplate code we had in our previous example. To get around that, the developers have provided you with the idea of a compact constructor. So a compact constructor now allows you to say, okay, I've got a record called range, takes two values, but now when I specify the constructor, I don't need to specify the parameters that I'm passing to it because they're already specified in the line above. We know what they are. We also don't need to explicitly assign the values to the instance fields because the compiler will do that for us. So that makes life easier. All we do is put our additional logic in there and we can do whatever we need there. One small thing to be aware of, because the example here I'm throwing an exception, is from the compact constructor you can only throw an unchecked exception. There is no way in the syntax to specify public range throws my exception. That won't work. So you can only throw an unchecked exception. Is the record? Yes, they are always final. Yeah, and in fact, I'll come back to that. Yes, so they are always final. Instance of. another thing that we are changing in JDK 14. Now, instance of is something that's been in Java right from the very beginning. It's an object-oriented programming language, so we have the idea of type hierarchies, we have the idea of polymorphism, so we can look at objects as different types. If we have a reference to a supertype and we want to determine its specific subtype, we use instance of to test against that. And this is classic piece of code. We say if obj instance of string, then the first thing we're going to do, because if we want to use it, we have to create a new variable called s of type string, and we have to assign to that the object reference and do an explicit cast telling it that it is string, and then we can use it. Now that's obviously a bit of extra boilerplate code. We don't really need to do that, so let's let the compiler do it for us. So now we have in JDK 14 pattern matching for instance of. Now pattern matching is a programming construct that's been around for a long time. It's been used all the way back to the 1960s. And in this case, what we're doing is pattern matching for types. You do pattern matching for different things, but this is pattern matching for types. What we're saying is if obj is an instance of string, so that's the pattern that we're looking for, the type string, then we'll use a type variable s, and that will eliminate the need for us to do the explicit cast and the assignment. The compiler does that for us. Because we're doing a test in the true branch of that, where we do have a string, the scope of s is valid. So we can call s.length, that will work. In the false branch, we don't have a string. So s, the scope, is not valid. We can't use s and it won't work. We can be a bit more clever. And we can also include an ampersand here, and we can, or an AND operator. And we can say if obj instance of string s and s.length is greater than 0, do something. And we know that in the AND operator, we always evaluate the left-hand side, and only if that equates to true do we evaluate the right-hand side. If that equates to true, then we know we have a string, so the scope of s is valid on the right-hand side. We can call s.length and test against it, and that will work. If we tried to do it with OR, that won't work because, again, we always evaluate the left-hand side, but only if the left-hand side evaluates to false do we evaluate the right-hand side, in which case we know we don't have a string, and therefore the scope of s is not valid and it won't work. The compiler will reject it. A couple of things to be aware of. One is we use what's called flow scoping, meaning that the scope of s may not necessarily be as quite obvious as you think it is. In this case, if we do if not o instance of string s, return from that method, s will then be valid for the rest of that method, because we're then passing a point where we've actually tested against it and we know that it is a string, so we can still use s. And then here's a question for you. Will this work? So if I create an object s as a new object, and then I say if s instance of string s, print out we've got a string of length s.length, else print out no string. So different results we might have here. So who thinks this will compile? Okay, one person, two, okay, a few people think it compile. Who thinks it won't compile? Okay, quite a lot of people think it won't compile. Who thinks it will work and won't work? Sort of quantum physics kind of superposition sort of thing. Okay, so the answer is it will both work and not work. What I mean by that is that, and this was really weird because I saw this on one of the mailing lists, is that if you put that in a file and you try and compile it with Java-C, the compiler will reject it. If you do it in your IDE, the compiler will reject it because it says S is already defined, so you can't redefine it. But it will work if you use JShell. If you use JShell and you run that, it will actually work. I have no idea why. I thought JShell built on top of Java-C, but apparently in that case, it doesn't. So I have no idea why that works, but it does in JShell. Text blocks. Again, preview feature. So we have the opportunity to make some changes to it if people think that things should be changed. In JDK 14, text blocks was a second preview feature, meaning it's still not final, still potential for some changes. What they did was introduce two new escape sequences that can be used. First of those is a continuation. Put a backslash at the end of the line, and that means we don't have a new line and therefore we can continue that onto the same line. That solves the problem of the extra blank line that we saw in the first example. So if we need to put some intentional indentation in, we can solve that problem. And also, because they decided to remove the trailing spaces, they now give you the ability to put them back in again. So by using \s, you can specify, yes, I really do want these trailing spaces on the end of that line. JDK 15. Java is an object-oriented language, and we have the idea of inheritance. So we can construct type hierarchies like this. Simple one, we have a shape and 3 subclasses, triangle, square, and pentagon. Now the problem we have is that in terms of defining who can subclass shape, it's all or nothing. Either anybody can subclass shape, or we mark it as final and nobody can subclass shape. What we really would like is to have more fine-grained control over the way that works. And the reason being that if I'm creating that set of classes, it's all good. I know what's going on, that's fine. But if I create class shape and I've got a colleague in another part of my project who looks at that and says, oh yes, I like shape, I'm going to subclass that in my code, then I come along and I say, actually I need to make some changes to the way shape works, and I know that I'm controlling these 3 classes so everything will still work. But suddenly the person who's subclassed from shape doesn't know I've made these changes, and they lose the ability to change the way it works, and things don't just work the way they want them to. In JDK 15, we now have the idea of sealed classes. Sealed classes allow you to control who can inherit from a particular class. You can think of final as being the ultimate sealed class because it's completely sealed. Now, although it's called sealed classes, it actually also applies to interfaces. And when I first saw that, I thought, well, why didn't they just call it sealed types? Wouldn't that have been better? And so I asked some of the people at Oracle, and they said, well, technically, an interface is a class. So I learned something new. So they can call it sealed classes. But there you go. The other thing that's important about this is that all the classes involved, or interfaces, must be relatively local. They've either got to be in the same module or the same package. And the way this works is by adding some syntax to the way we define a class. What we now do is add a modifier to say that in the case of our class shape, it's public sealed class shape, and we add a permits clause which specifies the classes that I want to be able to subclass shape, triangle, square, and pentagon. That replicates my type hierarchy that I had before. If somebody else comes along and says, I like shape, I want to create a circle subclass, then the compiler will reject that and it will say, no, because it's not specified in the permits clause, it's not allowed, and so it won't compile.
Yes. Doesn't this kind of create a circular dependency?
A circular dependency?
Yeah, because
Don't think so.
with the triangle will only have dependency on shape. Shape doesn't have dependency on triangle.
It's not a dependency. It's merely specifying that triangle is a permitted subclass.
Okay. A soft dependency.
Yeah, it's a soft dependency, but it's not a. I don't think it causes a problem in terms of the definition of the language or so on.
Okay. But can you specify something that doesn't exist yet?
Oh yes. Yeah, you can certainly specify a class that doesn't exist because you're saying at some point in the future I might want to have that, but it doesn't check the triangle, square, and pentagon exist. There's no requirement to do that.
What is a module?
JDK 9, module system. So modules are a sort of higher form of packages. So in JDK 9, they introduced the module system, which is where packages are logically grouped classes. Modules are logically grouped packages. So that's the answer to what a module is. JDK 9, look at that. Oh.
Sorry, does it work with the solid principle at all?
In terms of?
The triangle and square, and that's a part of the solid, one of the solid principles.
Right.
Is it in this, or
Where
where you have the least
Oh, I see. Yes. Yeah, it should still work because it doesn't change the way that inheritance works. All it's doing is specifying that there's only a set of valid subtypes of that particular class. So it doesn't change any of the actual inheritance capabilities or any of that. It's just limiting the number of classes that can inherit from that class. So I don't think it would have any impact on that. Now, in terms of the subclasses of a sealed class, you have to explicitly specify the inheritance capabilities of each of them. And there are three ways of doing that. So the first of those is to further extend the fact that it is sealed. So you take triangle and you say that's sealed, and we can specify further subclasses like isosceles and equilateral. Second thing we could do is we could take square and we could stop any further subclassing of that and simply say it's final. And then the third thing that we can do is to, if you like, unseal the class and allow anybody to then inherit from that. And this uses a hyphenated keyword. So this is a big thing in Java because it's the first hyphenated keyword that we have in the language. So non-hyphen sealed as a modifier on a particular class. If it is a sealed subtype, then it becomes unsealed and anybody can then inherit from it. And don't worry about the fact that there's a hyphenated keyword. This is contextual keywords. So it doesn't impact on the ability to use things as variable names. It's only a keyword when it's used in that context. Because as somebody pointed out to me, you could have variable non and variable sealed, and then if you take sealed away from non, you get non minus sealed, which is non-sealed. But that works in terms of the compiler. We'll quite happily deal with that. So like I say, you have to have all three types, or all three things can be specified, and everything that's a subtype has to have its inheritance capabilities specified. Second preview for records. Again, a couple of minor changes. So what they did was they included the idea of local records. And this is really nice because it makes things easy. If you want to use a record just in a particular method, rather than creating a record as a separate thing and using it only in one place, you can put it in a method and make your life a lot easier. So what I've got here is a simple example where I'm passing in a list of people who are selling things for me, and I want to order them by how much they sold in a particular month. Now, clearly I can do that because Java is Turing complete, so I can do it in many different ways. But in this case, what I'm going to do is use a local record called sales, which is a tuple of the seller and an amount that they sold. And then when I take my stream of sellers, I can map that to a stream of local records using the seller and then calculating how much they sold in that month. So I'm now getting a stream of tuples, pass that through sorted, and use how much they sold in that month to order them. So now I have an ordered stream of local records, map that back to the sellers from those local records. So just extract out the seller. So now I'm back to a stream of sellers, collect that into a list, and I've got my result that I want. And it's nice and simple because by using that tuple, I'm passing multiple things between the different parts of my stream. So it's a really nice way of doing things. JDK 16. So JDK 16 didn't actually have much in the way of, well, it didn't include any new features in terms of the language. A couple of things did become final, as in, like, they're now part of the standard. So pattern matching instance of became a full feature, as did records. And one of the things about records, because there was the question about whether all the fields are final. So one of the things they said in JDK 15 actually was that the fields in a record are now truly absolutely final, meaning you can't even change them with reflection. So it's not like just normal final fields in a class. In a record, you cannot change the value of them, even using reflection. They did make a couple of minor changes to pattern matching for instance of. First was they said that the pattern variable is no longer explicitly final. That was how it was in the past. And they said it's a compile time error to compare an expression of type S against a pattern of type T where S is a subtype of T. So you have to read that a couple of times to figure out what it's saying, but essentially it's this. So if I have a method where I pass in a rectangle and I say if R is an instance of rectangle rec, print out what the rectangle is, well, that's a stupid test because, of course, if I'm passing a rectangle in, then it's always going to be a rectangle. So that's always going to pass as true, and the compiler will now reject it. So it will say, no, you can't do that. It's already a rectangle. JDK 17, bringing us right up to date. So more pattern matching. This time we get pattern matching for switch. Now, if you look at switch statements, switch expressions, we're limited on what we can actually switch on. It's either an integral value, it's a string, or an enumeration. What they've now done is expand that into type patterns that you can match against. So it's very much like type pattern matching for instance of. Here's an example. So I pass in an object, and then I can switch on that object, and I can have different cases for that. First of which is null, because I might want to test to see if I've actually got a null, and null is a sort of rather special type in Java, so we need a case for that. Then we've got the idea of a specific type, string, and we have a pattern variable s, so that on the right-hand side, if we want to print out what the value of s is, we can do that. Similarly, if we've got a color, we can call the getRGB method on that to use it and find values from that. We can't have a case for a primitive, because a primitive in Java isn't a type, but an array of primitives is a type. So if we've got an array of ints, then we can do system.out.println and the length of the integer array. And then if we've got anything else, we do as default and print out whatever the string is. Now, pattern matching for switch has completeness. What I mean by this is that if I have this piece of code here, so I've got a switch on an object reference, and I've only got two cases, string s and integer I. Now, if I pass in something other than a string or an integer, what do we do? I pass in a float. What does the compiler do? Well, we could say, well, because we haven't dealt with that case, we just ignore it and we drop through to where the rest of the code is. But that really loses some of the value of what we're doing here. And the designers said, well, let's make the compiler check so that if you've forgotten to put things in, then it becomes apparent at compile time rather than at runtime. You therefore need a complete switch statement or switch expression, meaning that in this case, if you excuse the pun, you have to have a default so that you cover anything that is not a string or an integer. And that way, all possible types are dealt with. Now, it doesn't mean that for every switch statement or expression, you have to have a default. Anybody guess what you could use which doesn't need a default? Nope. Ah, very good. Yes, a sealed class. So if we had our shape that we used before, then because we know that we have only a certain number of subtypes of that, then we can have a switch on shape and have case triangle, case square, case pentagon, and case shape. We know that all of those possibilities are now covered. We don't need a default because there's nothing in our type hierarchy that could possibly exist outside of that. A couple of things to note is that the compiler will obviously check the completeness of that. It will also warn you if you fail to compile if you move the shape higher up in that list.
Wasn't the pentagon unsealed in the class, or?
It doesn't matter, because if it's unsealed, it's still a supertype of the... so anything that's a subtype of pentagon is still a pentagon. So polymorphism works in that case. I had to think, I thought exactly the same thing when I was going through these slides earlier on. I thought, hang on, I said pentagon was unsealed, so what if it's something that's a subclass pentagon, but it would be caught by pentagon. So it is complete in that sense. So yes, if you move shape higher up, shape would hide things lower down, because of course it's the superclass, so it would match first. So the compiler will not let you do that. It will say, hang on, you've got other things which are subtypes of that. Yes, if you had a subtype of pentagon, then you could put that in there and that would work. This is still complete because it covers all possible supertypes, but you could add further subtypes and that would work. But again, you'd need to put a subtype of pentagon above pentagon in order to avoid the pentagon matching first.
Not for the seed case, but you said that it hides further down. What happens if you have interfaces type matching and there are multiple choices, one hiding the other? Is that also an error, or is it just picking the first?
It would pick the first that matches. Yeah, definitely.
Secondly, is this also a switch expression, or is it only for switch statements?
Switch statement, because this one is actually a switch statement.
Yeah, sorry.
Yep. So that it works for both switch statements and switch expressions. Yep. Okay. You can also have guarded patterns in the same way that we had the idea with instance of, where we can use an AND operator. Then in this case, we can say if it's a triangle T and calling T.area is greater than 25, then we say it's a big triangle. Now, if that fails, we might still have a triangle, so we have to have a case for triangle, and that will match anything that's not a triangle that's greater than 25, so we call it a small triangle, and then we have the rest, and that's still complete. So we can do some, interesting things with that. Right.
Sorry, what happens there if you get that? Will it do an exception?
Yes. Okay. Yeah. If you pass in a null and you try and call T.area where you don't have a reference, then you'll get a null pointer exception, which is why you might want to put a case null before that. But that doesn't prevent null pointer exceptions. Okay, so the last bit I want to talk about, because I've got about 10 minutes or so, is making Java faster. So how can we do that? Well, if we look at the way Java performs, what we tend to see is a graph like this. And this is a result of the fact that we are running in a managed environment. We take bytecodes from our class file and we run those through the JVM. And several things happen. When we start off, we get low performance. And this really goes right back to the early days of Java, when Java was criticized as being slow. The reason being that we had to interpret bytecodes. Every time we saw a bytecode, we converted it into the instructions for the platform we're running on. To solve that, we introduced JIT compilation, just-in-time compilation. You compile code as it's running. And the way that works is that you look at how many times a method is called. When it hits a certain threshold, you say it's a hotspot in the code, hence the name of the JVM, hotspot. And you pass that to the C1 JIT compiler. That's designed to compile code very quickly, but doesn't optimize it. So you get slightly better performance because now it's running as native instructions rather than interpreted, and it gradually warms up. That method then gets used more and more, hits another threshold, and it gets recompiled in using the C2 JIT compiler, which then takes profiling information that's being collected whilst the method's being used, optimizes it based on that, and delivers a much better performing version of the method. We also see some dips in performance as that happens, and that's down to what's called de-optimizations. One of the big things about JIT compilation and the way that we get better performance from that is through speculative optimizations. We assume that if the code is run a particular way up until that point, that it's going to run in the same way in the future. So if you've got an if statement, always gone through the true branch, let's optimize based on the idea that it's always going to go through the true branch in the future. Maybe at some point you go through the false branch, we have to throw away the code, recompile. So that's a de-optimization. Get to a steady state in terms of all the hot methods are being compiled, recompiled, and so on. But we still see dips in performance, and that's due to good old garbage collection. So automated memory management. What we do at Azul is we created a thing called Platform Prime. It used to be called Zing, if you've heard of that. And the idea behind this was to say, we can do better. What can we change in terms of the way that the JVM works to improve performance? Rather than starting from scratch and doing something like J9 from IBM that's a clean room implementation, we said, let's take OpenJDK and then change certain parts of it. Most important part is that having made those changes, we then run all the TCK tests and we verify that it works in exactly the same way functionally as Hotspot and any other TCK tested JVM. Meaning your application doesn't have to be modified, the code, don't have to recompile it. You can just run it on the same way. Functionally, it will be identical. Performance-wise, it will hopefully be better. can't guarantee it, but hopefully it will be better. What we've done in terms of changes, firstly, is to remove all the garbage collectors from Hotspot, so G1, CMS as it used to be, Serial, Parallel, Shenandoah, ZGC, all of those, and replace it with one called C4. C4 is the Continuous Concurrent Compacting Collector. Key thing about that is it is concurrent. There are no stop the world pauses in our garbage collector, meaning that your application doesn't have to be stopped in order to do the work of the garbage collector. And that's where you tend to see pauses introduced for doing that work. Second thing we did was to replace the C2 part of the JIT compiler. So we introduced a thing called Falcon, which is based on an open source project called LLVM, might have heard of, which is a compiler project. And that allows us to generate better, more heavily optimized code. The other thing we've done is Ready Now, and that's designed to eliminate as much as possible this warm-up time. Because when you start the same application again, it goes through the same process of learning which methods to compile and recompiling them and doing the same thing. Why not take a profile with information about which methods are compiled, how they're being compiled, and then use that when you start your application up again? And that's what we do. A couple of things is, one, we only support this on Linux. And the reason for that is because we do some clever things underneath in terms of memory management at the operating system level, either through specific system calls or through a kernel module that we can install for very large heaps. And what it allows us to do is to scale from 0.5 gigabyte of heap to 20 terabytes of heap without seeing any increases in pause times associated with garbage collection. And we actually do have people running 20 terabyte heaps. They want bigger. We can't quite, it's one of those bizarre situations. We use the object header to index into the heap. We need to find one bit to go beyond 20 terabytes of heap. In terms of how that changes the performance graph, Ready Now is all about moving that graph out so that we can get to that optimum level of performance as quickly as possible. C4 is all about removing these pauses due to garbage collection, and Falcon is actually about raising the level of the optimized code and therefore the throughput that we can get. To prove this works, what we do is we use a thing called jhiccup. Jhiccup is a thread that you run alongside your application in the same JVM, and it's designed to monitor the latency of the JVM itself and everything below it. So we're not looking at the latency associated with the application code, it's the latency introduced by the JVM itself. And we produce graphs like this. Take an Elasticsearch 128 gig heap, run it twice on the same machine. Same workload, exactly the same setup, just run it first time with Hotspot, second time with Prime, and then graph the results. What we can see here on the left-hand side is a very typical Hotspot graph. Lots of small spikes in terms of latency due to minor GC pauses, so collecting the young generation. Two big spikes, which are due to major GC pauses. On the right-hand side, we've got Azure Platform Prime, and you might think to yourself, well, hang on, if spikes are bad, I see lots of spikes on the right-hand side. Why are you claiming that this is really good? I have been deliberately misleading. I have scaled the graphs differently. So on the left-hand side, we've got 0 to 8 seconds, meaning we've got half second minor GC pauses, 5.5, 6.5 seconds major GC pauses. On the right-hand side, 0 to 80 milliseconds. And if I scale the graphs the same, yay, wonderful. We just eliminate all the problems of garbage collection, just like that. Cloud native JVMs. So this is some of the things that we've been doing more recently, and there's some quite interesting things going on here. Cloud native compiler. Now, if you think about a JVM, as I've already described, you have a JVM that does certain things, one of which is JIT compilation. And each JVM does its own JIT compilation. So why have all of your JVMs run independently if they're in the cloud? So they're in the cloud, they have network connections, they can talk to each other if they need to. Why have them all run independently? Why not take advantage of connectivity, and why not take advantage of the fact that you have in the cloud effectively limitless resources? Why don't we change the way that things work? So what we've done is come up with what we call the connected compiler. And what we do is effectively take the JIT compiler out of the JVM and move it to a cloud service, so that you've got the compiler as a service. This is really good because now we can centralize the compiling resources that we use, meaning that we can share that amongst multiple JVMs. Now, if you think that you've got, let's say, Cassandra or Kafka running, and you've got a cluster of nodes running the exact same application. So why does each of them need to go through the process of compiling code to run the same application? Why shouldn't we do that centrally and share the code amongst those JVMs? We can reuse the codes when the node is restarted, so we don't have to do the compilation again. We know what we've compiled. We just reuse it from a cache, from our service. And this is also really good for microservices, because microservices, you've got much more limited resources in terms of the container. So why use a lot of those resources to compile the code for your application? The other thing that we're working on at the moment is to sort of take that to the next level, which is to say, okay, if we've got limitless resources, why not spend a lot of time really trying to generate heavily optimized code and applying all sorts of weird and wonderful techniques to the way that we can generate that code to get even better performing applications out of that. Just to give you a sort of example of how this works. So this is, if we think about standard optimization, that's the orange line. Now, in terms of throughput, that gives us quick warm up and we get steady state throughput. Fine. And if we look at the CPU utilization over time, then we see heavy CPU utilization at the beginning because we're compiling code, and then it drops down to a steady state where we're running the application. That's all good, but if we want to try and optimize more heavily, we need more compute power to do that. So the result of doing that, if we do it in the same JVM with limited resources, is we spend more time doing compilation at the beginning, so heavy use of our CPU, which degrades the performance of our application initially, and eventually we get to higher throughput, but it's still a bit unstable as we kind of compile code and so on. So it takes quite a long time to get to that stable value, which is higher. If we use the cloud native compiler, move the JIT compiler out into a separate service, then we immediately see that we get straight up to our optimum level of performance, and we get that high level of performance, and we even reduce the CPU utilization because we're offloading it to a different service. If you think about that in the cloud, if you're running your Kafka cluster or your Cassandra cluster, that means you can do one of two things. You can either reduce the size of the instance for your nodes, or you can reduce the number of nodes in your cluster. Either of which will save you money because you're paying on a utility-based model, and that reduces the cost. Now, yes, you've still got to pay a little bit for the actual compiler service, but the reality is that that will be less than your save in terms of the running the multiple nodes on your system. Last thing I want to talk about, this is another kind of research project that we're doing, which is Java on crack. I think the marketing department might need to have a little think about that in terms of how we name it. But what this is what's called coordinated restore at checkpoint. And this is all about microservices. How can we get super fast startup for microservices? A lot of people have looked at things like GraalVM and native images as a way of getting fast startup for services that are run in a container that are in Java, because you create a native image, you're running straight away with native code. Problem with that is you don't take advantage of the JIT compilation side of things, so you don't get heavy optimization, you're limited in terms of things like class loading, reflection, bytecode generation at runtime, all those things don't work. So this is a research project we started about doing pause and resume of a JVM. And we now actually have it as an OpenJDK project, so you can go onto OpenJDK and you can find crack. And yeah, it's based on some of the work that's been done on Linux, which is CRIU, checkpoint restore in user space, which is where you pause an application and then you can restart it at some later point and have it carry on at the same level of performance. That was originally targeted at live container migration. Key part is coordinated, because if you simply freeze an application that's running and you say in Java, let's just take a copy of all the registers, the stack, and all that kind of stuff, and then restart it at some point later, that isn't going to work, because if you've got open files, open network connections, that's all going to fall apart. So the coordinated part is that you have an API that allows the application to say, right, at this point we're going to take a checkpoint. So we'll close the files that we have open, we'll close the network connections, and then when it gets restarted, it can immediately say, right, I know I've been restarted, I need to open these files, I need to re-establish these connections, and then I can carry on with the work that I'm doing. So it is very much a coordinated way of doing things. And in fact, if if it doesn't do it right, you can actually refuse to do a checkpoint. Generic CRAC API, CRAC API, and the idea is to coordinate between the application code and the checkpoint restore functionality. We're doing this in a generic way so that if there's different ways of doing the storing of the application state underneath, it will still work with the same API. As an example of this, we've done a proof of concept. It's on GitHub under CRAC. And this is the kind of results we get from this. So Spring Boot, this is really good, right? So Spring Boot, time to first transaction, if you run it from cold, that's about 4 seconds on the machine that we used. If you use a checkpoint restore, 38 milliseconds. So that is 2 orders of magnitude faster. That's the kind of thing where you can think, right, microservice, want to be able to start it up really quickly. Rather than 4 seconds, 38 milliseconds. And that is still with all of that optimization that you get from JIT compilation. You've got the speculative optimizations, all of that good stuff built in, 38 millisecond startup time. Same Micronaut, 46 milliseconds versus 1,000 or a second. Quarkus, which is super fast startup for things, even that 980 milliseconds comes down to 33 milliseconds, and XML transform, which is probably not the best benchmark, but it looks good. So 4.5 seconds down to 53 milliseconds. So you can see the kind of results we're getting with this. It is a research project. It's not production ready yet, and there's still some stuff we need to do with this, but it's very interesting in terms of being able to deliver that super fast startup time with the heavy optimization that you want for overall performance. Just briefly mention Platform Core, because I'm running out of time. In fact, I'm sure I have run out of time. But this is what we provide as our build of OpenJDK. As I said, there's the idea of multiple distributions. This is ours, which we support all the way back to JDK 6. So if you're still running applications on JDK 6 or JDK 7, we also support 8, 11, 13, 15, and 17. I think we support more versions than anybody else at the moment. Wide platform support, 64-bit versions for the usual suspects, 32-bit versions if you're still running Windows XP, things like that, and full support 24/7/365. Very much complete drop-in replacement for other JDKs. It's TCK tested, so no need to recompile any code. To summarize then, I think the 6-month release cycle is working really well. It's definitely delivering more features more quickly than we've ever seen before, and it is helping to take some of those rough edges off the way that the language works and just help improve it and keep it popular. There's other things coming down in terms of OpenJDK, things like Project Bloom, Project Valhalla, Project Panama. Haven't had time to talk about those, but these are bigger pieces of work that will, again, keep Java very sort of relevant to different applications. OpenJDK, definitely the way things are being developed in terms of the Java platform, and you do have more choice in terms of Java runtimes. And as I would say, if you're looking for a build of OpenJDK, we have Zulu or Platform Core, either free or supported, and we also have Platform Prime, which you can try out as a high-performance version. And with that, there is the free t-shirt survey that you can fill in again. I'll leave that up because it's now actually working. And I will say, if anybody has any questions, I know we've had questions throughout the...
Is it possible for preview features to be in the long-term support?
Oh, yes, absolutely. Because the thing about long-term support is it has no meaning as far as OpenJDK is concerned. OpenJDK doesn't understand long-term support. Long-term support is only a factor of people who provide distributions. Because how long long-term support is for, And how you deal with that is up to whoever provides your distribution. From the OpenJDK's perspective, each one is only 6 months long. And if somebody wants to continue contributing to that project and leading it, then they can do that for as long as they want to, which is why at the moment Azul, one of our engineers, is the lead on JDK 7. Let's see, Red Hat is one of their engineers is the lead on JDK 8. I think SAP might be the lead on 11. And then we've got engineers who lead 13 and 15. And Oracle leads 17 at the moment. So yeah, long-term support can have preview features in it just as much as any other. Okay, good.
I'm really curious. Maybe we can take that out afterwards. But I mean, the cloud compiler and all that look really sweet. I'm just curious about the versioning. If you have, same application, you just compile it, and you're still running some other seasons.
Yeah. So this thing, because of course, JIT compilation is done by method. So if you change a specific method, yes, we will have to throw away code. But what we've even found is that there's a lot of overlap, because if you take a method, you might change some of it, but we still have the ability to reuse some of the code that we've generated. And again, this is where it's still sort of work in progress, but we have found that there's a lot of overlap. We don't have to do as much work as we thought we had to do, even when somebody recompiles a method. Obviously, if you completely change the method totally, then that's invalidates what we've done. But there's a lot that we can reuse, from a class, because it may be only 1 or 2 methods that change. And even with methods that do change, there's still kind of work that we can reuse. Okay. Well, thank you very much.